I have a lot of friends who tell me they're taking a physics class, but they have a hard time with kinematics. They know how to use the equations, but they don't know when to use which one. So that's what we're going to be looking at today. The way this is going to work is I will show you an example and I'll guide you through figuring out which equation to use. And we'll do this by looking at what we are given by the problem that I've created. Before we do that, let's just look at what variables we're working with and the three equations that we're going to be using and how to read them. So our variables are t, the amount of time taken, v sub I, or v sub 0, which is also called v naught. This is initial velocity, or the starting velocity. V sub f, which is the final velocity. D, which is of course the displacement, and a, which is acceleration. Now in equation 1, we have Vf equals Vi plus At. So when we use this equation, we can find the final velocity using the initial velocity plus the acceleration times the time taken. Equation 2 tells us we can find the displacement by multiplying initial velocity times time taken plus half of the acceleration times the time squared. We can find the final velocity squared by squaring the initial velocity and adding twice the acceleration times displacement. Now, the third equation that I just said is a little more interesting than the other two because there's something that the other two equations have in common that the third one does not. To use this third equation, you don't need the time. It's called the timeless equation. So, now that we know how to read each equation and what our variables are, let's look at some examples. So, starting from rest, an RC car accelerates at a rate of 6 meters per second squared for exactly 5 seconds. What is the final velocity? So, before we do any calculations, let's just keep track of what we know. When you see starting from rest, that means the object is not moving at the start of the problem. So the initial velocity is going to be 0 meters per second. The question also directly tells us the acceleration and the time taken. So right now we have 3 values, and this is actually everything we need to know to find the final velocity. So now we just need to figure out which equation to use. And remember that we're trying to solve for the final velocity, but final velocity, as you can see, is not involved in equation 2 at all. So that's not going to be the one that we're going to be using. In equation 3, we can get the final velocity using the initial velocity, acceleration, and displacement. We have initial velocity, we know the acceleration, but we don't know the displacement. So equation 3 will not be the one that we'll be using. With equation 1, we can find the final velocity using the initial velocity, acceleration, and the time taken. And those are the 3 variables that we know. So equation 1 will be the correct equation for this problem. So now physics, we're completely done with physics. Now it's just math. We'll just plug in the values and the equation will do its thing and tell us the final velocity. So it's 0 plus 6 times 5 is equal to 30. So our final velocity is 30 meters per second. So if you look in the top left, you'll see I have an extra practice problem. So you can find the displacement from this problem. I'll give you a hint. You are not going to be using the same equation. You'll have to figure that out on your own. And the answer to the extra practice problems will be at the end of the video. So you can do that on your own. Alright. So let's look at the next example. An egg is dropped from the roof of a school and it takes the egg 1.4 seconds to reach the ground. Find the total displacement of the egg. So whether you know what terminal velocity is or not, you can just ignore it for this problem. We're not going to be worrying about that. It's a little bit more advanced if you're starting, if you're just starting kinematics. So now we have a special name for problems like this where an object is falling. Specifically, it's falling freely, and they're appropriately called free fall problems. So in free fall problems, when an object is dropped, that tells us the initial velocity is 0 meters per second. And from the question, or from the problem, we also know that the time taken is 1.4 seconds. Now, the problem doesn't say anything about acceleration, but we actually know what the acceleration is. When an object is falling, there is acceleration due to gravity. And this is represented by a lowercase g. So before I tell you what the value of the acceleration actually is, let's just think about it for a second. The egg only has two directions to go in this situation, either up or down. And up is the positive direction and down is the negative direction. So since the egg is moving downwards, it's accelerating downwards, the acceleration is going to be negative. So it's going to be negative 9.81, or we could just say negative 9.8 meters per second squared. So at this point, we now have everything given by the problem in front of us. So now we just need to figure out which equation to use. Which equation lets us find the displacement using the initial velocity, time, and acceleration. So take a second and try to figure that out for yourself. Okay, so it's going to be the second equation. After subbing in our values, we can find the displacement to be negative 9.6 meters. Now, solve the extra practice if you want, and we're going to look at the third and final example. A car is moving at 20 meters per second. The car decelerates at a rate of 1.25 meters per second squared. How far does the car go before stopping? If you can't tell, this question is asking us to find the displacement. So we know from the problem, the initial velocity is 20 meters per second. The deceleration is 1.25, so the acceleration is negative 1.25 meters per second squared. And since the car stops and is not moving at the end of the problem, we know the final velocity is 0 meters per second. So we want to find the displacement, but we don't have the time. So we can't use equation 2. With equation 3, we don't have the displacement, but we do have the other three variables. And displacement is what we're solving for. So with some algebra, we can rearrange this equation, or as my modern physics professor likes to say, we can massage this equation and isolate D. Another way you could figure out that you need the third equation is that we don't have time. And the third equation is called the timeless equation because we don't need time. So from this equation, we can find the displacement to be 160 meters. And those are all the examples I have for you. To raise the number of dimensions in a kinematics problem, you need to do a different calculation for each dimension. So if you want a video on multi-dimensional kinematics, just let me know. But eventually I will probably be making a video on projectile motion anyway, which more often than not has at least 2 dimensions. And as promised, here are the answers to the extra practice questions. Alright, that's it. I'll see you in the next one.